there, welcome to Applications of Systems. So on this, we're just going to focus on how to solve a system using a matrix. So you will definitely need your graphing calculator, as you can see on the left side of my screen, ready to go. So first things first that we want to go ahead and look at is, before we jump in and grind things down, we want to take a look at this quick little example, because you're going to see this appear a little bit throughout our lesson today. So here we're looking at 3 times something gives me 15. So normally we would see this multiplication, and to solve, we would simply divide everything by 3. And we'd end up with a really nice answer like x equals 5. So whatever that variable was, I know it would be equal to 5. And the good thing is we're choosing things like division because we know that those operations will undo each other, or they're also called inverse operations, whichever one works a little bit better. So you'll kind of see that in our lesson today. So keep in mind as we continue. So before we jump all the way to there, we're going to go back and look at how to write a matrix given a system. And you're going to see this matrix right here. All of your variables are back in the game. So before, we never saw those. So now you do have a variable matrix. Over here, when you see 5, 6, -3, and 8, we call this your coefficient matrix. And again, coefficients are all of the numbers in front of your variables. And then this last one over here, we call the constant matrix. Constants. So basically no variables involved. So the way that we always see these, instead of writing all of these long words, is we always can say A, which is our coefficient matrix, times our variable matrix is going to give us all of our constants. So you can already see where that first idea came into being. So I think you'll start to see how we can solve, but we're going to come back to that because we're just focused on writing the system. So the good thing is, all we're going to do is take all of these coefficients. So I see a +5, a +6. Variables go in order. So x goes first, and then y, and it shows +6. +6 is equal to -10. And there's one of your equations. That's it. Final answer. Same thing on the bottom. So I've got -3x, and I see a +8y. So +8y. And then this one is just going to give us +15 for a final answer. And that's all. That's how you write from one to another. So go ahead and pause the video and try this one on your own. All right, welcome back. Hopefully you're going to see this one looks a little bit different because I've given you the system and now you're going to the matrix. You're also going to see a couple of missing variables. So on this first one in purple, looks like everything is lined up. I've got my x, then I have a z, and then I have a constant. So that one's good to go. Ooh, so I wrote that one the exact same way. So I'm going to keep that one, not going to change it. The green one, you can see it's a little out of order because I have an x here, a y here, a z here. So I'm going to reorder all of that to put my x's first, then my y's, and then my z's. Always be sure everything is in order. It's going to make a big difference when we're writing this matrix. Okay, and on the third equation, you probably already see something a little different because one of your variables is not on the other side. So let's go ahead and move it to the other side by subtracting it. And the good thing is now it looks like we just have nothing left on the other side. So again, rearrange. So I've got -5x right here, +6y minus z, and there's no constant. So everything in purple. So I have 5x, no y's, 1z. And then in the green, it looks like I've got -12. So I'm going to keep them in order, kind of like this for you. +5, -9, +1z goes to 0. And then in blue, I see a -5, +6, -1 goes to 0. And then all your variables, x, y, z. So that goes based on how this is ordered. So x, y, and Z. So order matters when you're building a matrix. Order is very, very important. Okay, so let's see how we're actually going to solve using this brand new setup. So the first thing you're going to do is you're going to rewrite as a matrix. So first things first. So I'm going to get all my coefficients. I'm going to get my variables and then my constants. And this one is nice because it doesn't look like I have to rearrange anything. So I see +4, +5. I see -1 and +1. All right, and then it looks like I kept my variables in order, so I didn't really move them around. So I'm going to do X and Y. And the very last thing I needed to do is, I think you're guessing it, is the constants. So I've got -3 and +3. Okay, so we're going to pause right here because this, I'm going to rewrite A, X, and B. So again, kind of like what we saw at the very beginning of our notes. Remember that we did this and we said to do the opposite. So we multiplied by the inverse. So we multiplied by 1/3 on both sides. So we basically did the opposite. So that is exactly what we're going to do with this one. Multiply by an inverse. It's just matrices, they have inverses, but I would never expect you to try to do it by hand, and I'm never going to make you. So to solve these, you're always going to do that. You're going to do A inverse, the whatever, basically you're going to undo this matrix, whatever that matrix is, and now look at that. Your variables are all alone. So it's going to make it go a little bit faster. So here's what we're going to do. Make sure you grab that calculator because this is going to make the biggest difference. So you're going to go to second and then matrix. Go all the way over to the edit screen. Tap on matrix A. Looks like I have a 2x2. And you're going to punch in all those numbers. Be sure you hit enter after every single one. That is crucial. So I'm going to drag that over so you can see my matrix A. All right, we're going to go back into the matrix. So second and matrix. Go over to the edit screen, select matrix 2 or matrix B. Looks like I have a 2-row by 1 column. I see -3 and 3. All right, looks like that one's good to go. So now I'm going to do A inverse B. So go ahead and quit. You'll see that right here in blue and go back to the home screen. This is where all of the math is going to happen. So now we're going to select matrix A. So which seems kind of weird, but that's exactly what we're going to do. So you're going to hit second, matrix. On the name screen, choose option 1, so matrix A. And right here on that button, you're going to see that -1. And then go back into the matrix and select B. Tap on enter. Congrats! You've just solved a system using a matrix. That's it. That's the entire process. A inverse B. The trick is to be sure you know which of those numbers is actually the number that you need. But the good news is, up at the top, we wrote that as our variable matrix. So that's going to tell me -2 and 1, X and Y. All done. All right, go ahead and pause the video and try to set up this matrix on your own, and then hit play to watch me do the calculator. Same exact idea. I always like to show this just so I know exactly what I'm doing. So again, I'm going to do the opposite, whatever that means in the matrix world. So I'm always going to show this step just to be sure I know exactly what I'm doing. So these cancel out. So my variables, when I solve, A inverse B, and it's always A inverse B. I think that's a nice little shortcut to jot down. So I'm going to jot that right there. All right, let's go into the matrix. So second button, get to the matrix, go all the way to the edit screen, choose option A. Now we have a 3 by 3 matrix, and we have 1, 1, 1, 2, 0, 1. And again, you're going to hit enter after every single number. That's going to make sure that everything gets saved. All right, looks like that's matrix A. I'm going to go edit matrix B, which is a 3-row by 1 column. Looks like my numbers are 0 and 12 and 3. All right, looks good. So go ahead and quit to go back to the math screen where all of it's going to happen. Let's go select our matrix, which is matrix A, inverse matrix B. Done. That's it. All finished. So I'm going to go ahead and write that matrix on my paper. So I've got -5, -2. And then hopefully you can see what each variable represents. So be sure, write it as an ordered triple. Done. Okay, so next problem we're going to take a look at is a word problem. Of course, you didn't think those were going away, did you? Of course not. Why would they ever go away? But luckily it's related to my caffeine intake, so hopefully we're not going to judge, because especially this problem says I'm getting 100 pounds of coffee. I'm sure that'll last me 2 days, maybe 3 if I'm taking it real slow. So the first part says I have French roast coffee, which is $5.20 per pound. And then I've got a Colombian option, which is $4 a pound. Says I'm going to make a 100-pound mixture and I'm selling it for $4.72 per pound. So first things first, go ahead and define your variables. So this is the French roast, and this is the number of pounds, so LB for pounds, if you don't know what that means. C is going to be my Colombian. Colombian, same thing, number of pounds. Well, the good news is they've told me that I am buying 100 pounds. So I can take my French, add my Colombian together. So all of my pounds together, how much I have, and I'm going to get a 100-pound mixture. So it's like pounds plus pounds gives me pounds. This is where the next one's a little tricky, because it says French roast costs $5.20 per pound. So however many pounds I buy. Colombian is going to be $4 per pound. And that's going to give me a price per pound? No, that's not how that works. But the good news is I know I'm getting 100 pounds. So I can plug that in right here. So if it helps, I've got a price per pound. So $5.20 times however much I buy, $4 times however many pounds, and then I should get $4.72 for my 100 pounds. So it's definitely a little goofy. All right, now I'm going to go ahead and write the matrix. You can see so far I have not used my calculator yet. I'm still writing and I'm still showing all of my steps very, very clearly. All right, so the first one says I've got 1 French roast, I've got 1 Colombian for 100 pounds. And then I've got 5. You can just do 0.2. If you put 0.20, you're going to get the same answer, $4. And I did my French roast, then my Colombian, and then this is 472. All right, so I'm going to clear this out. I don't need it anymore, so I'm going to hit second into the matrix. I think you know to go to the edit screen, you always have to edit matrix A, so 2 by 2. So you'll see every time you change it, it will override what you previously did. So you don't have to try to clear your calculator at all. All right, I'm going to go back into the matrix. You have to hit that second button to get there. Matrix B, so that's a 2 by 1. I have 100 pounds and then 472. All right, A inverse B. So second quit to get back to the math screen. Let's go grab them. Back to the matrix A, inverse matrix B. Final answer. All right, so 60-40, and this is where it's going to matter how you labeled your matrix, because you can see that these numbers could easily get flip-flopped if you aren't paying attention to which ones are which. So here I can see F, here's the first one, Colombian is down there. So be real careful when you write these. So I'm going to put the French roast. I'm going to go ahead and label it. So I bought 60. I'm going to put pounds, so units, and then Colombian. I bought 40, and I'm going to put LBS for pounds. So on word problems, it's helpful to label the final answer. A coordinate may not be as helpful. All right, go ahead and pause the video and try this one. It has 3 variables. All right, welcome back. You can see I've already highlighted a couple tips and tricks to help you set up your equations. Hopefully the first thing you did was define your variables. That will be worth points. I need to know what your variables represent, especially with soda and salad. So don't choose S twice. So it looks like I have 2 pizzas, 1 liter of soda, 1 salad is 14, 1 pizza, 1 soda, 3 salads is 15, 3 small pizza, soda, and 2 salad. So there are your 3 equations. Let's see, there we are. So there's A matrix, all those numbers you can see that I pulled. X, so P, S, and D, so pizza, soda, salad, D for salad. And then hopefully your matrix looks something like that. Again, A inverse, because I have to move that to the other side. You'll see my little arrow. And here's that final one. You can see I've labeled it P, S, and D. You'll see I highlighted something in yellow because the question says how much is 1 pizza and 1 salad. So always go back and read those questions. These are what are going to make these a little trickier. So make sure you've answered the final question. But that's all there is to it for this one. So I chose X, Y, and Z to be the smallest number, the middle number, and then the largest. You don't have to choose X, Y, and Z. You can pick any variables. If you like A, B, and C, you can stick with that. I have a lot of people who chose S, M, and L because it helps them remember the smallest number, the middle number, and the largest number. So it's really whatever makes the most sense to you is what you can rock and what you can roll with. So the first one, it looks like I have the sum of 3 numbers is 16 in math, so there's equal. And then let me bump that over. So here's kind of what my equations looked like. And then you can see the one in blue, so the largest number, which I said was Z, is the sum of the other 2, X and Y. And then you can see 3 times the smallest is 1 more. So again, is in math is an equal, 1 more than the largest. And then I boxed find the product. So before I set up my matrices, you can see I've drawn some arrows to help me remember to move some things over because everything has to be aligned in a matrix. I boxed my first equation since I didn't need to move anything on it. So I wrote a word up here, augmented. So to help us keep all of these matrices organized, this matrix where you kind of combine all the equations like we did on the previous lesson is called an augmented matrix. So if you liked what we previously did, we did reduced row echelon form. You can use whatever method you want when you solve these. I do not care which method you'd like to solve with. So if it says use a calculator, you can do reduced row, or you can easily do the way that we've been doing. And here you'll see that you'll get the exact same answer. So you can see 1x, 1y, 1z gives me those 3 numbers. And then be careful because it said find the product. So multiply all 3 of those numbers together. Welcome back. So you can see that this problem is different than the one on the paper. I realized there were a couple little errors, so I had to adjust mine. So hopefully you got a chance to compare that. All right, so write and solve a system. So it looks like I have 3 different candies, Nerds, Airheads, and Skittles. So I'm going to just show that part first. There we are, Nerds, Airheads, and it looks like it's cost. So I put a $sign. So is it bags or is it cost? All right, it says I remember some things about the cost. Biggest thing I'm looking for is which one is the most expensive. So on the first one, I have a couple different equations. So here are the 3 that I created. So I have 3 bags of Nerds, 6 bags of Skittles, 5 bags of Airheads is going to give me $33.75. I have Skittles were twice nerds, so Skittles S are twice nerds. And then Airheads A are 75 cents less than Skittles. So 75 cents from Skittles should give me Airheads. You'll see that I had to move a couple of equations around. So I moved and subtracted this to the other side, and then I moved this. So variables on one side, my numbers were on the other. So here were those equations that I created. All right, next thing is to create the matrix. So I'm going to show you both ways. So depending which method you picked, I have both answers ready. So if you chose the augmented matrix with reduced row echelon form, that's hopefully what your matrix looked like. And you found that Skittles were the most expensive option. So that was my second number that I put in. Okay, if you chose the other one and looking kind of like this. So again, you can see those matrices are real similar, very, very similar setup. Here's where I did A inverse B. Oh, look, it's the exact same answer. Skittles are still the most expensive option, running at $3. So again, you pick the method that works the best for you. Completely up to you. I do not care. Just be sure that you show all of your work, you show your matrices, you show that method. That is super critical, super important. All right, I will see you in class and we will do a little bit more practice. Have a great day.